Hello everyone and welcome back to the Chiblo Devlog series. In this episode we are diving into the Chiblo guts. This video will be more technical than the previous ones, so you will need strong programming and OOP basis in order to understand everything. Finally, I do not pretend that the way I did things is the best, it is just how I ended up working. I am also presenting how things work at the time of writing this video, so they might be subject to change in the future. I will be covering subjects such as game algorithm, game logic and data structures. With that said, let's get dissecting. The first question I asked myself was what architecture I was going to use. I originally planned on using a standard OOP based approach, but I was struggling to figure out what classes to use, so I made a list of different things I knew I wanted to implement and starting from there. I used the following objects: player, mob, particle, NPC, item, door. I knew everything in the game would fall down to a generic entity class, so I went from there. Then we see that we can have player and mob inherit from a common class, a fighter class, and that class will be using a controller class for inputs. NPCs and fighters share some properties, so I added an actor class. Then I noticed both NPCs and doors can be interacted with, so I added an appropriate interactable class. By now, we can already see problems emerging with the diamond inheritance right here. I don't remember exactly since it was a year ago, but I do remember running into problems trying to add other types of objects in the game. After questioning my life choices for nearly 2 weeks, I finally found a solution to my issue. I dropped the OOP and it was time for me to work with an ECS. ECS stands for Entity Component System, and it's a different way to approach a program's architecture. Where the OOP focuses on concepts, ECS focuses on data. Everything in the game has different components that represent attributes, and an entity just holds the list of components it has. The beauty of it is that you have incredible flexibility with your components and can even change the entity component list at a runtime. Usually an ECS also comes with an event system, but I haven't worked on that yet. The difficulty of an ECS is that it's difficult to implement, and finding the proper components is a whole other issue. Of course, as you might have guessed, because I hate myself, I decided to ignore the very efficient, professionally used existing libraries like Entity used in Minecraft, and I went to write my own. The core classes of my ECS are the Entity class, the Entity Manager class, and the Component class. In my version, I do not have systems as the update code is stored directly in the component. An entity here is just an index, and a list of indexes for components. The actual components are stored as different arrays inside the Entity Manager, which also holds the entities. When updating the ECS, the Entity Manager sequentially updates the different components with a precise order, as some components depend on others to function. I don't know if that is the right way to do it, but it's how I ended up making it work. Now when it comes to choosing the component, I have no experience, so I do not know if the way I did it is correct. My approach was to divide components based on logical divisions. First, I created a component that stores map data. The vast majority of entities will be needed in this component, as it also handles movement and collision. I also added different components for the different types of rendering too so far. This might change as I am a bit unsure if it's really necessary, considering the rendering isn't simply a loop through components. In the same idea, I separated the animation data into a different component, which might also get absorbed back into a global rendering component. I also added a controller component. This links an entity that has any kind of map behavior and isn't static, and that allows me to abstract the controls to a different area in the code. Instead, this component simply interfaces with the controller and calls its function. More on that later. The last two components have to do with fighters. I separated stats blocks and what I call breed. The breed component simply links an entity to its data file, and the stats block represents the entity's current stats and attributes. Finally, I added a corpse component to represent dead or dying entities because they have special treatment. Finding the right way to interface the controller with the entities proved to be a challenge until I stumbled upon this video during my research. What I then did was that I created a series of actions that the entity can perform, and the controller interfaces with the entity by creating different actions. Actions are basically mini state machines that perform very simple tasks: idling, moving, attacking, and so on. The controller component logic becomes very simple. First, if the current action is done, we ask the controller for the next action. Then we step the current action. The controller creates actions based on either player input or AI decisions or even networking, and can be easily swapped during runtime in a completely transparent way. This could lead to a small class bloat, but the flexibility is well worth it. That's it for today's video. You can catch me programming live on Twitch on Mondays, Wednesdays, and Fridays, link in description. Thank you for watching, and see you next time.